Good afternoon, everyone. My name is Rikhuo, and today I'm going to be presenting on my SIC project, Student Dropout Prediction. So, universities today they face problem with student retention, and why is it a problem? Because it affects both the students' future and the institutional planning. Okay. So the question is, can we use ML and data to identify the students at risk? In order to further explore that question, I trained certain ML models using dataset that contains demographic, academic, and socio-economic information about university students. Initially, there were three target variables: dropout, graduate, and enroll. And the goal is to predict whether a student will drop out or graduate eventually. Now we'll move to the next step, data pre-processing. In this step, the data was cleaned and made suitable for training the ML model, and we removed enrolled students to make it a binary classification problem. Then we also converted target variables to binary, that is 1 for dropout and 0 for graduate. Then to help the ML model better capture relationships between the features, we engineered three new features. That is grade interaction, which multiplies the first semester grade with the second semester grade. It is to capture the overall academic performance, and the next is approval interaction, which is used to measure academic progress, and also grade per edge, which relates academic performance to the student's age at enrollment. Now, training and testing. We split the training and testing data sets using an 80-20 split. And okay, now the four models that are used: logistic regression, random forest, and gradient boosting and XGBoost. Logistic regression is a very common ML algorithm used for binary classification. Random forest, it uses multiple decision trees, and gradient boosting and XGBoost are advanced algorithms which are very commonly used in competitions. And next, I also applied feature scaling using standard scaler for logistic regression. Okay, now after training my models, the models were evaluated using certain performance metrics like accuracy, confusion matrix, ROC curve, precision recall curve, and cross validation. We'll have a look at the accuracy scores. Here, the logistic regression, it had an accuracy, it scored the highest accuracy, around 94%, and closely followed by gradient boosting and XGBoost. All of them scored pretty good. And to better understand the model's prediction, the confusion matrix was also used. It provided a detailed view of the model's predictions. Let us have a look at the logistic regression. In this case, the model correctly predicted 421 graduates and 262 dropouts. It made 21 false positive predictions and 22 false negative predictions. Overall, the number of correct predictions is much higher than the errors, indicating that the model performs well at distinguishing the classes. Now the ROC curve. Okay, it plots the true positive rate against the false positive rate at different classification thresholds. The diagonal line that you can see is the random guessing, and while curves closer to the top left corner indicates better model performance. In this project, all the models achieved high area under curve scores close to around 0.97, showing strong ability to distinguish between dropout and graduate classes. However, among them, gradient boosting achieved total score. Now the PR score, it was also used to evaluate model performance, particularly for the dropout class. The graph shows average precision score, which summarizes the overall performance of the model at different thresholds. All the models achieved fairly high average precision scores, indicating that they perform very well in identifying students who are at risk of dropping out. Now, these are the classification reports. Okay, to validate the scores, I have also used a 5-fold post-validation technique, and the accuracy that I got using it was very close to the original accuracy scores, which showed that it's consistent and the data is not overfitting. Now we'll have a look at which features contributed most to the prediction using analysis from random forest model. So as we can see, the curricular features, that academic features, they contributed most to the prediction. Features like curricular units, then approval interaction, that's the engineered feature, then approved grade interaction, etc. They all contributed highly for the prediction. These are the same, but then in tabular format. Okay, in conclusion, the machine learning models achieved strong performance in predicting student dropout with accuracy around 94%. The analysis showed that academic performance plays the most important role in determining student outcomes. These findings suggest that predictive models like this could help universities identify at-risk students and improve retention strategies. Thank you.